Hello, Knox Knights. My 8th graders are going to be doing a scientific notation flipped video. You're going to need a highlighter and a pencil and your composition notebook. Once you get those out, then you can proceed. Go ahead and turn to the page titled Scientific Notation in your composition notebook. It'll be on whatever page your teacher gave you this foldable to glue on. We're going to go ahead and copy down a couple of words. The first one is standard form. Go ahead and underline that. Standard form means numbers that we regularly write. So they're just regular numbers. So for example, we have 12,142 or 0.125 or 125 thousandths. Those are regular numbers. That's how we just write numbers every day. There's a special way to write numbers, and that's called the scientific notation. So the next word you need to write is scientific notation. Go ahead and underline it. Scientific notation is a special way to write very large and very small numbers. So is a shortened way to write big and small numbers. Well, who uses scientific notation? Well, as you can tell from the name, scientists use scientific notation. When you're talking about astrology or how far away planets are, those are really large numbers, so they'll write them in scientific notation. Also, you have people who work in the medical field and we're dealing with really small numbers, like the size of a cell or the size of a molecule. They'll write numbers in scientific notation. Now, there is a format and a special way to write in scientific notation. If it's not in this format, it's wrong. So let's go ahead and talk about what that format looks like. On the first tab of your foldable, I want you to go ahead and draw a line, a decimal, and then little lines that follow at the end. So what does that mean? Well, we're looking for just one number, a decimal, and then after the decimal you can have as many numbers as the number allows, or the number that you're given. Go ahead and open up the flap. This number represents a whole number. And this number must be from 1 to 9. So it's only one digit, okay? So you have a number and then a decimal, and you can have as many numbers after. On the bottom flap, we're going to go ahead and write only one number or digit to the left of the decimal. So there should only be one number to the left of the decimal. That's how you write the first part of this scientific notation. It will always be times 10. So in that second flap on the outside, go ahead and write times 10. Okay, on the top part of the flap, we're going to write will always be times 10. If it's not times 10, it's not in scientific notation. Also, this number is important because it will have an exponent on the 10. So you're going to see on this last flap, it's going to have an exponent. So we're going to go ahead and draw a line kind of towards the top where the exponents are usually located, and another number sign. Go ahead and open up that flap. On the top flap, we're going to write exponent. The second bullet, the exponent shows the number of times the decimal moved. shows the number of times the decimal moved. And we'll do some examples in a little bit. The third bullet, positive exponents mean the standard number is greater than 1. So positive exponents mean the standard number is greater than 1. So we're talking about numbers like greater than 1. So 2, 1,000, 10,000, 1 million. Those will have, in scientific notation, positive exponents. We can also have negative exponents. Negative exponents mean the standard number is less than 1. So when we're talking about like 50 cents or 125 thousandths, those are numbers less than 1. So in scientific notation, they'll have negative exponents. Let's go ahead and do some examples underneath the foldable. All right, so for example, let's say I give you 2.05 times 10 to the negative 6. Is this number in scientific notation? Well, is there one digit to the left of the decimal? Is it times 10? Does it have an exponent? In this case, all three are met, so this is correct scientific notation. Let's look at another number. Let's write 81.25 times 7 to the 10th power. Here we have two digits to the left of the decimal. We do not have times 10, and the exponent's okay, but here, this is not in scientific notation. We have two digits, and it's not times 10. So that's why it's not in scientific notation. All right, so how do we change from standard form to scientific notation? Well, let's do an example. Standard form to scientific notation. Go ahead and write down 17, 300, 000. All right, now that we wrote this number down, we need to identify how are we going to change it in scientific notation. Well, first off, we need to find where the decimal is right now. The decimal is all the way to the far right. Where do we want the decimal to be? Well, we need to have one digit to the left of the decimal. So that's where I want my decimal to go. Now I'm going to count how many times I need to move the decimal. So there's 1, 2, 3, 4, 5, 6, 7. I need to move the decimal 7 times to get it so that I have one digit to the left of the decimal. So this number in scientific notation is going to be 1.73 times 10, and then the exponent is going to show how many times we move the decimal, which in this case is 7. Now we can write a positive 7 or a negative 7. So we need to go back to the standard form number and say, is this number bigger than 1? Is 17,300,000 bigger than 1? In this case, it is. So we're going to write the standard number is greater than 1, which means, let's go to this side, we're going to have a positive exponent. Okay, so when we have standard numbers that are greater than 1, we have positive exponents in scientific notation. Let's add another example. Let's go ahead and write down 0.000803. Okay, so how do we write this number in scientific notation? Well, we need to identify where the decimal is going to end up. So we need to get one digit, and then a decimal. So there is the one digit to the left of the decimal. So now we need to count how many times we need to move that decimal. In this case, it's going to be 1, 2, 3, 4. So this number in scientific notation is going to be 8.03 there's our 1 digit to the left of the decimal, times 10, and then how many times did we move the decimal? In this case, we moved it 4 times. Now we need to go back and look at the number in standard form. Is this number bigger than 1? Well, if I look at it like money, I can say that, is this number bigger than $1? In this case, it's not. So our standard number is less than 1. Well, what does that mean? That means that if it's less than 1, we have a negative exponent. So go ahead and write that down. So we need to put a -4 for our exponent. Let's go ahead and write a couple of examples on how to go from scientific notation to standard form. All right, let's write down 1.94 times 10 to the -5th power. So I want to write this number in standard form. So I don't want the times 10 and the exponent anymore. So how do I get rid of it? Well, I have to look at the exponent. That tells me which direction to move the decimal, -5. So I need to go to the left where my negatives are. I need to move the decimal 1, 2, 3, 4, 5. So in those spaces, I'm going to go ahead and add zeros. 1, 2, 3, 4. So this number in standard form is going to be 0.000194. Let's do one more example. Let's go ahead and write down 2.71 times 10 to the 3rd power. In this case, I'm going to look at the exponent again, and since that is a positive number, I'm going to move in which direction? Well, positive numbers on the number line are to the right, so I need to go in this direction. That's a +3. So I need to move the decimal 3 places to the right. 1, 2, 3. So I'm going to add a 0, and this number in scientific notation is going to be 2710, because we moved the decimal behind the 0. All right, good job, you guys. See you later. Bye.